The evidence for machining. So this is the cutting and polishing of stone, and of very, very hard types of stone in particular. You're talking about things like granite and basalt and diorite, which are, if anyone's familiar with the Mohs scale of hardness, can be anywhere from like 6 to 8 on the Mohs scale of hardness.
This is the Mohs scale of hardness?
MOHS, Mohs scale of hardness. So it's basically like, you take a harder material, and if it scratches the surface material, another material, it's harder than that. So it starts at, your fingernail's like a 2 or a 3, and then diamond is the top of the scale at a 10.
Okay.
Yeah, so you get to 10, and that's the top scale. So, steel, iron is like a 5.5, 6. Steel is like a 6. Things like that. So you're talking about stone that's harder than steel.
Okay, wow.
Granite.
Holy
Basalt's a little bit harder. There's even examples in that, and we'll get to it with the vases, but there's examples of stuff made from corundum, which is a 9. Like, it's literally just about as hard as diamond, but there's vases made from this that display all this evidence of machining. So it's not just the fact that these stones were used, but there is evidence in the stonework of frankly power tools. Something's been used to carve these stones at a very rapid rate. Yeah, so there's some examples.
So this is different. He's talking about some of the bigger stones with like the flat surfaces, right?
There's a good saw cut. Yeah, there's a good one with an angle on a saw cut you can find, but that's not a bad example either. That's still that's part of the machining discussion, and that's a bigger tube. That's an even bigger tube drill.
Michael, look for one of the pictures of the rock that looks like it was cut by a big circular saw.
Yeah, go to it's in tooling.
When you showed some of these, like, you were pouring water over the top of these things that were cut flat.
Yeah, so you can see the striation. So when it comes to machining, you're talking about different types of cutting techniques. There's tube, like circular saws, tube drills. There's also straight saws, and after that you have machining and like polishing. So there's just not a natural.
This isn't it, Michael.
That's one of them. That's a cut that's into a block of basalt at Giza. Keep going.
Looks like it was cut down the center.
Yes, it was. Yeah, there's a number of examples of that on there, in that directory.
No, Michael.
There's an example of circular saw cut being dipped into basalt, which is harder than granite, by the way. More. So
could a normal like concrete saw, like a demo saw, cut through this rock?
Yeah, it could, because tile saws and things like that are they're diamond tip blades. So that's the closest analogy we have to the evidence that's in the stonework. So that's the thing. There's been a bunch of, I dive into a lot of the experiments and the research that's been done in these, the history of investigation into these different types of cutting. So tube drills, circular saws, cutting stones, the grinding method, the pounding stones. This has been an ongoing discussion for 150 years. There's been people that have been looking at this and scratching their head for like 150 years and going, this can't have been done with these primitive tools that we've found in the archaeological record, versus the establishment saying, well, these are the tools that we found, so therefore these must have been the tools that we used. And it's just like, you can't use those tools to show us the same result. Something else was done. And we know what tools the dynastic Egyptians
used. There you go.
Yeah,
that's one of the great examples.
Yeah, so this is one of my favorite examples, actually. So this is a block of stone that's at a place called Abu
Can you
Sir.
full screen this?
But yeah, so there's a block of stone at Abu Sir that is.
Oh, there you go. You just passed it.
It's nearly cut all the way through.
Keep going. There you go.
That's a different one, but that's fine. That's a good example too. That's actually a place called Abu Rawash. So you see the arc, right? There's a clear circular arc to this stone.
Yes.
So it's either a drops. It's like what you would call a swing saw, or a circular saw that has cut this stone. And the one that we saw earlier that's at Abu Sir actually has a little lip at the end of it. So it's like it hasn't quite cut all the way through the stone, but there's a little like over lip that's still there from thousands of years of weathering. And through that little lip, we can tell that the blade of this thing was very thin, a couple millimeters at best. And when you measure out the arc of it, you're talking like 30 feet diameter, like some huge processing plant cutting this. And then you also see striations on the stone itself that shows you how that saw progressed through the stone, which was quite rapidly. Now, this is amazing evidence, because you can now sort of determine the rate at which the saw progressed through the stone, which turns out to be quite rapid. And you can compare that to the experiments that have been done in the orthodox model, which says that, well, what they did was they got a big copper bar and they just ground sand with water on it, and they just went back and forth for days and days, days and days. And there's been a bunch of experiments that look at how long that takes. And these are like a couple of the like guys like Dennis Stocks that are on the mainstream side that have done a little bit of work on this. And it's just the numbers are insane. And you don't get the same marks using that technique. And one of the major problems with it is that you wear away the copper bar at about the same rate that you're wearing away the stone. Right. So, and when you start to extrapolate that, so for example, I think I calculated that there's a box that's in the second pyramid at Giza, at Khafre's pyramid. It's a granite box. It's like 10 feet long and 4 or 5 feet wide. And using the experiments and the rates that we've done to do the grinding method, just to make the 6 cuts that you'd need, so north, south, east, west, top and bottom, 6 cuts, you're talking a year of labor to cut that one box, to make those cuts using copper bars, a year of just grinding. And that doesn't include how they hollowed it out and everything else, just the base cuts. And when you extrapolate that to the tens of thousands, if not hundreds of thousands of granite blocks, of basalt blocks, of blocks from other types of stone that have all had to be quarried out first from the quarry, which takes just as long, if not longer, with these primitive methods, shipped to the site, and then cut down to basically their dimensions. And then you've probably got years of work. Just this is with primitive methods, years of work on top of that, just finishing it and hollowing it out and doing all the other stuff.
So I was right in the Giza power plant, and like I said earlier, a friend of mine recommended that I submit an article to Analog Magazine, which I did, and it was published in '84. So that was called Advanced Machining in Ancient Egypt. Mm-hmm. And in that article, I referenced the Petrie core and relayed what Petrie wrote about it. That it was a tapered core, came out of a hole, presumably, that exists in the Valley Temple, and that it had a spiral groove. That the grooves were 100 thousandths distance apart, and that he checked like 4 turns of it, and claimed that it was a true spiral. And he also said that the groove was cut deeper in the quartz as it was the feldspar. Okay. So when I was trying to figure out, using my machinist tool-making background, what kind of technology could create those kind of features,
right?
I proposed that perhaps they had used ultrasonic machining, because ultrasonic machining is not, it's not like a conventional type machining where, conventional drilling of granite, as I learned from an ultrasonic or a conventional granite manufacturer, Rogan Granite in Ohio. They conventional drilling holes, the penetration rate was like 2/10,000ths of an inch per revolution of the drill.
2/10,000ths of an inch per revolution.
So if you look at 100,000ths per revolution, that's like 500 times greater than conventional drilling.
Okay.
It's an impossible feed rate in granite. So,
and you can figure out the rate by the distance between the grooves?
Yes.
Okay.
Right. And that's where the controversy began, is that I proposed a method that was totally unacceptable, ultrasonic drilling, which is where you use vibration to impact the granite and remove material, and then advanced the tool into the granite using a screw and nut method, as you can see there with the capstan at the top, and you just put pressure on it, moving it into the granite. Use a slurry, which will actually do the cutting. And then there is a taper on the bore and the outside of the tube drill, and that taper, the tube drill will wear as it is penetrating the granite, and that is reflected on the core and the hole as a taper, right? So that was just my idea. just a simple idea. It received limited attention in after the article was published. There was a couple of protests, one by L. Sprague de Camp, who objected to it. He wrote a book called The Ancient Engineers, and so he claimed that, the working of stone by the Egyptians is well known. Went through the whole list of, copper, copper tubes and bashing stones and stuff like that. So I responded to his email, and then that was pretty much it. And then in 1995, I was invited to participate in a message board discussion on Deja News, and there was a guy called Rodney Small who had read my article in '84, and evidently it had become a point of discussion on the Deja News archaeology message board. So I joined in, and that was my first taste of message board discussions. And yeah, and so after, I don't know, maybe 1,000 or so posts, it kind of petered out. I don't think anybody changed their position on
This was what year, roughly?
1995, I think.
Ooh.
Yeah.
You've got mail.
You've got mail, right? Yeah, the old key.
Yeah. That was before that, probably.
No, it was actually 95 when I first got online.
Oh, was it really?
Yeah.
Oh, wow.
Yeah. Yeah, so I was on AOL. I'm still on AOL.
Are you really?
I know, people look at me strange like that when I say that. Yeah, I'm still
Good
on
for
AOL.
you.
Still have the same email.
Still holding strong.
I don't know about strong. Holding.
Okay.
All right. So then, after that, there was a book published. It was by Chris Ogilvy Harold and a guy called Lawson. Oh, I forgot his first name. I'll think of it. So anyway, they wrote a book called Giza the Truth, and in that book they report on an examination of the core by two people, Reed and Brownlee, who go to the Peter Museum where the core is located, and they determine that it's not a spiral, that it's a horizontal groove. Okay. So I looked at that, I read that, and I was like, well, okay, interesting. But it looks like the core is slightly tilted, and that would kind of throw you off when you're trying to visualize the core, the spirals, and it's, yeah. So I was still on Petrie's side, but I was willing to be proven wrong.
Mm-hmm.
There's infrastructure on these sites. At Saqqara, at Abu Sir, at Dashur, at Giza, we have evidence for very complex systems of what I can only call channeled blocks, these U-shaped blocks that are below the floor level. So you have these floor tiles that might be a couple feet thick. In some cases, they're even cased on top of that, but right down beneath that stuff, you have this infrastructure of essentially piping. It runs all under these sites. It's all over the place at Abu Sir. We see evidence for it, Giza, Saqqara, like all these old kingdom sites. Not something you ever see on the later sites. These are the oldest of sites, have these very strange and complex, essentially either it could have been housing piping, it could have been housing cables, it could have been, we don't know, but and sometimes it's not all gravity fed, like sometimes they'll run all the way down beneath causeways to where there would have been water, and then it runs all over the site in complex patterns. At Abu Sir, it's probably the best example. There's Y-joins and all these other things running beneath the floor, and sometimes using fairly exotic stone types like granite or white calcite or alabaster. And a lot of those stones show evidence for machining. There's a great example at Saqqara of machined alabaster U-shaped channeled blocks that are beneath the floor tiles, and it's a real mystery. We don't know why. I mean, it's like if you ask the explanation for what this white calcite or alabaster was used, it was prized for its white color. It's an expensive stone to try and use. It's difficult to obtain. Alabaster And calcite comes from, extinct and calcified natural springs. Like these are millions of years ago were natural springs. They've calcified over time. And to get white calcite, you actually have to dig all the way to the source of the natural spring. So it's wherever that was. It's not like an easy stone to get to. Further out from the source, you get sort of yellow calcite and brown calcite, but they were using white calcite. And Egyptologists say that they prize that stuff for its color, for its clean color, or sometimes it can be transparent. In that case, what is this stuff doing buried beneath the floor level where it's never going to be seen? Like, it's literally a stone type that gets used in this underground infrastructure that's never seen. So they must have been using it for some other purpose. Like, I think some of these stone types that you see, particularly in the really megalithic stone sites, might have had a functional purpose, like choosing particular types of stone, like basalt, granite, limestone, white calcite, even quartzite in some places, and in particular orders. And there's plenty of other indications that there was something else going on at these sites. I mean, my last video I did on Karnak Temple, there's some really interesting. There's an area of Karnak that it's normally off limits. Again, we know the right people to get in and see it, and I love showing people this stuff every year. There's a part of Karnak where the granite's literally crumbling apart. It's granodiorite. It's something's happened to the stone here where it's like the inside of the stone has swelled, or it's like it's undergone a transformation and it's expanded. And it's almost around the edge of the stone, there's a couple of inches of where the stone is in good condition. But because the inside's like transformed and expanded, it's put this pressure on the outside, and it's cracked all of the outside. And in some places it's like falling apart, like it's cracked the whole blocks apart, and then the inside of the blocks just crumbling
from the inside out.
Yeah, inside out. And
so wild. And
then we see that also at Abu Sir and other places where you have like crumbling basalt. And this happens in nature, right? But it takes literally millions of years of exposure. It's but championed by Chris Dunn, by the way, a friend of mine, an author guy I respect greatly. I interviewed him on my channel. He wrote a book that he's well known for called The Giza Power Plant that suggests that the pyramid was essentially a device for producing energy, and he explains every facet. What's interesting about his theory, to me personally, that still sits within like, well, we're trying to use our perspective to kind of explain it. Mm-hmm. But what's interesting about it is that he does explain every aspect and element of the pyramid in that. And using his theory, he successfully predicted what was behind Gatenbrink's door, which is like a whole other. There's a couple of these shafts that run out of the chambers in the Queen's Chamber in particular was the one they're talking about. There's these shafts that run out. They're very small, like 10, 12 inches sort of wide.
Is this like when you look at like the anatomy of the pyramid?
Yeah, you see these little shafts.
Can you Google the anatomy of the Great Pyramid and we can have a visual for this? Yeah. But yeah, so there's the tombs in there.
Well, there's the King's Chamber. Well,
chamber.
So-called. Okay. I call them so-called King's Chamber. There's an upper chamber, a lower chamber, and then the subterranean chamber.
Right.
It's so also called the King's Chamber, the Queen's Chamber, and subterranean chamber. Now, there is shafts that lead out from the King's Chamber that eventually reach the outside of the pyramid. The Queen's Chamber ones terminate somewhere inside the pyramid. And when they finally sent some robots up there to look at it, they found, whoa, there's a door here. Like this little shaft eventually terminates with a little limestone door and what looks like copper handles in it. So they eventually said, we'll get another robot, get a drill, and we'll stick a camera in there and have a look. And so Chris Dunn, using his theory, successfully said, well, under this theory, what you should find after that door is a space and another door. And that's exactly what they found. So yeah, there you go. That's this image here shows you the upper chamber. The red there is the what you would call the King's Chamber with it has a series of chambers above it that are all these essentially 70-ton granite blocks that are all stacked up in its internal structure. And it has these shafts labeled as 10 on this diagram that reach the outside.
So the shaft, what's the shaft that put the camera down where you saw the door?
Not like 7, I think, is the 7, the Queen's Chamber shafts. Yeah. Okay. Yeah, so that's, yes. I mean, by the way, you got to understand the ridiculousness of the orthodox explanation for all of this is that so when apparently when Khufu had this built, he was going to be interred in number 7 there, what's called the Queen's Chamber, and then he changed his mind and said, you know what, put it further up in the structure and do that. And they just built it on the fly, which is absolute nonsense. I'd like to point out, like, the precision of this structure is rarely matched to today. And in fact, wasn't matched until the 1800s in terms of how precisely the Great Pyramids aligned. And there's about a million other aspects to the Great Pyramid that we could talk about.
Oh yeah, we don't like this. Fuck it. Let's make it a little bit taller.
Yeah, make it a bit taller. Like, then that's the idea. They did this on the fly. It's absolute nonsense. And I have a couple videos that look at this stuff too. Is that one of the things that's remarkable about it is the structure itself is interesting, but the actual foundational work that went into the ground to prepare and build on top of is just as interesting, like an engineering challenge and puzzle, because they must have spent years and years preparing the site to basically take this object. And this is the case both with this pyramid and in particular the middle pyramid, because it's not on flat ground. They had to prepare the ground. Like they literally, the whole thing's locked into the ground with these foundational tiles of limestone that some of them weigh like 150, 200, 300 tons. And it's dug down, and they created a foundation layer for the pyramids. And in particular on the middle pyramid, it's actually built into a sliding, like a sloped hill on the I think it's it's the western side of the pyramid is like it's cut down about 30 feet. So you can actually go around, if you go around the western side of the middle pyramid, it's like this 30-foot wall where they've cut down into the bedrock. Then they've leveled that out, and then they've built up at the eastern side with these huge tiles, and then they've built this like millions of tons structure on top of it. And some of and they've actually used the bedrock to lock it in too. So instead of like taking all the bedrock out, they actually, like on the southwestern corner, the top 5 courses of that pyramid are actually bedrock. So it's not tile, it's not like blocks. They shape the bedrock, and then it just integrates with the slope of the hill into the rest of the structure, to where all the way on that eastern side they built it up with foundation tiles and locked it in. So that whole thing is just locked into the bedrock. Like that's one of the reasons it's still standing and they resist earthquakes so much, is that they are so well designed, and there's been so much engineering about how these things are locked into the bedrock that they have put up with all these earthquakes, and they're still standing, versus so many of the other structures from ancient Egypt that were done later that have all fallen down.